Hello, and welcome to another edition of Dev Wednesday. This week I have a little bit to talk about with this little crab right here. I found him, and I think we're going to be talking about Rust and WebAssembly. Um, so that's what I thought was like a pretty good stream for this week, and we're going to just hang out and do some Rust today. There are some other videos that we've done in the past, and kind of like the theme of everything is that I've been thinking about what is like the emergent stack that I'd like to be invested in, or what I think that other developers are interested in, and I guess like where the web meets, not just the modern application deployment where we have literally everything running inside the browser, and we want to be able to achieve faster and faster bindings to the, now maybe not just to the file system, but to uh, the entire program. So it's really interesting what you can do. There's been a lot of tutorials that I've been going through today, and I was inspired to go through just the Rust Wasm tutorial on GitHub. We're going to go through basically like a tutorial on how to do it, and like if anybody in chat has an idea or thinks something is cool, please tell me. If things are too loud, I'm trying out a new setup today. But yeah, we're gonna set it up. I did cheat a little bit and installed Rust on this laptop, but we're gonna go through like a hello world. We're gonna and more importantly, we're gonna talk about an implementation that was interesting that I thought was the game of life. So if you're not familiar with Conway's game of life, let's get like a visual introduction. Let's see if I can get this loaded up. And it's visually interesting. So we're going to talk about Cellular Automata. Interesting concept. I'm going to tie it in with Rust and WebAssembly. It seems they have a repository that we're going to try to get running while we're coding today. Let's try to look at a video real quick and see if this carries over. Nice. So it's Conway's Game of Life is a famous Cellular Automata program. Let's see if we can get it playing. Let's see. So the universe of the Game of Life is an infinite two-dimensional orthogonal grid of square cells, each of which is possible states dead or alive. Okay. We're going to keep this music going just to make like, make it like a little bit more interesting here. Okay, so we got the dead or alive. That's cool. So, all right, 1 second. I'm going to sneeze. Hey, chew! I'm sorry, I sneezed. Every cell interacts with its 8 neighbors. Okay, so if it's a square, it's got 8 neighbors. The cells are horizontally and vertically adjusting. Vertically, diagonally adjacent. At the end of each time generations, the following transitions occur. Okay, let's keep it going. Any cell can live with fewer than 2 live neighbors. It dies is caused by underpopulation. Any cell with 2 or 3 live neighbors lives on to the next generation. Any cell live with more than 3 neighbors. Any cell with more than 3 neighbors dies as if by overcrowding. Any dead cell living with exactly 3 live neighbors becomes a live cell. Cool. Now let's watch this with these simple rules. What happens? Whoa. I'm just going to cue the music here. Because it kind of looks cool from here. So you can see with like these simple rules, we can get some pretty good variances. And we're going to try to get this. And you want to have the render time be pretty quick while you're in browser too, so we can get to these patterns. And I think it's pretty cool. Take a second and just jam out and listen to see what's up. I thought these were astounding. Wow. Wow, that one's cool. So you get these like gliding effects as it's getting to the center, and it kind of looks like, so it's like you're producing these little genomes as they're flying off. That's so cool. Kind of these huge ones. It's like a little city that guy managed. You got like your little shipping containers here. That's pretty cool. Okay. So we got like a whole city going on here. Wow. Whoa. This one's pretty cool. I really like this one. This one was cool. It's pop, stop. Very cool. This looks like hieroglyphics. It's got like a little tree over here. That's pretty tight. And this little like squirrel that got flattened out in this upside down tree. You mean like these like spiders coming down through here. It's pretty neat. Whoa. So this is where it starts getting tricky. This is so crazy. So it looks like you guys, you get all these like life forms that form out of these. Whoa. The editing on this is pretty tight as well. So it gives us something to work towards. If we can actually start implementing a little game of life, then I would feel that this stream is fairly successful. Got more gliders, and this one I think they started to figure out how to like produce letters and whatnot. Like golly, holy. This one I'm not sure what it's doing, but it looks like it's making some sort of clock. That'd be so crazy if that was a clock. And it looks like it's getting this collapsing structure. Wow. This looks pretty fractal. This one's super weird. This one's like, this is almost like a Castlevania level. Oh, I think I'm in the way of that one. Whoa. This one's like if it creates a glider with these three just like coming verging, and this is like Samus falling down like, yeah, see? That's what I'm saying. What? Whoa. That one's cool. Looks like the Mega Crab Glider. Whoa. Anyone just joining? We are checking out interesting Conway Game of Life stuff because we are going to be programming a game of Webassembly Game of Life. Welcome if you're just joining. We're just going over things. This is a really cool one. Wow. That one looks like it's a video game. It's like you're immediately, it's like one of these Galaga, like bullet games. Like, oh, wow. This looks so sick. That literally looks like a got a couple more minutes of this just for inspiration. I thought this was epic, so I threw it in today. Because we'll see it. We're gonna go through the tutorial. Whoa. That was cool. So what I'm going to do now is switch over to my desktop, which we're going to see if we can get this loaded up. Perfect. Wonder if Justin's on. Justin, does my sound good? And we got a ref. Okay. So this is rustwasm.github.io. So if we just like go under, maybe we can go back. Look up Rust WebAssembly. WebAssembly is the open standard that defines a portable binary format for executable programs and corresponding textual assembly languages, as well as interfaces for facilitating interactions between such programs and their host environment. The main goal of WebAssembly is to enable high-performance applications on web pages, but the format is designed to be executed integrated in other environments as well, including standalone ones. Perfect. So this is where Rust and so during this one, let's see how to read this book. Well, we're gonna read along this time. So Rust and WebAssembly together. So this one is for the comedy game of life. Let's just make this bigger. Come back in. Cool. Conway's Game of Life. Okay. That's almost inaudible. So this tutorial is for anyone who's already a basic Rust and JavaScript user. Okay, cool. What we'll learn how to set up the Rust toolchain. I already kind of did this already, so we'll just keep going with it. I work for polyglot programs made from Rust, WebAssembly, JavaScript, and HTML and CSS. Even better. How to design APIs to take maximum advantage of both Rust and WebAssembly strengths and also JavaScript strengths. Okay. How to debug. How to time profile. I don't know if we're going to get through all of this, but we're going to get through a lot of it. I think that, yeah, that's good. Okay, so follow these instructions to install. Alright, if you have it installed already, I already have. It's detected I'm running Mac here, so it's giving me curl proto to install Rust up. Looks like you're running Mac OS or some Unix-like operating system. So please take your time and install this. Notes about this, toolchain management, path configuration. I made sure that my cargo bin's already configured. That's for everyone to figure out. But at the end, you should be able to see Rust compiler version. Let's see if we can actually run that. So we should be able to say Rust compiler version, and it's installed. Glory. All right. So let's go back. We're going to be installing Wasm pack. This is your one-stop shop for building, testing, publish, generated WebAssembly. Okay. Cargo generate helps you get up and running quickly with a new Rust project by leveraging a pre-existing Git repository as a cargo. Okay. npm. I have that installed. Let's just make sure that we have everything installed. So get your Wasm pack. And that's where the crab came from. I thought he was so cool that I literally got him for the stream just because he was super cool. I thought he was cool. He's like a baby Yoda crab. It's like, oh, I'm a very powerful crab for WebAssembly. Very cool. So I did this already. Looks like I'm on a Mac system, so I installed it already. Let's see. Okay, I already did that. So let's see. Wasm pack should be there. Yes. Cool. It's got a little sparkly package. Ashley Williams, thank you. And you can build, log in, so we could add npm for this user account. Okay. New, pack, publish, and test. There's nothing that we're going to test just yet, other than it being installed. This one's cargo generate is already installed, and my npm is already solved. Okay, cool. So let's go to the top here. Hello world. This is the quintessential John, as it were. This section will show you how to build and run your first Rust and WebAssembly program. I do suggest you go alongside of me, and then let's see. Okay, so I'm going to say, let's make a new live directory for, well, it says we're going to clone first. Let's see what we're going to do here. See what's inside. Alright, so the first thing is going to be cargo generate. So if we're looking at this, we're going to say cargo generate. Might as well make this big. Cargo generate git. So this is why we installed it earlier. Let's call that over here. Bing. Project name. Tells us to make it the Wasm Game of Life. Wasm Game of Life. Okay. So done. New project created. Very cool. Let's go over here. So let's go inside and let's look at the contents. Okay, so we're gonna go in there. Wasm Game of Life. Let's just bring it studio code to do this. Let's close this guy and bring up this one. No, we did this wrong. Did we do this wrong? Let's take a look at the contents. So we'll see. Very nice. Here's the GAN. Okay. So we're going to see that we have a cargo, we have the license, we have the lib.rs and utils. Let's see if we can see that. Here's the cargo.toml. Make this a little bigger so we can see what we're talking about here. But this looks like where everything is saved. You can see I'm the author. addition. Let's make this 21. Okay. Cool. This is where all the dev dependencies are. Wasm bounding test. Tell recipe for smart code size. Okay, very cool. So the cargo.toml file specifies the dependencies and the metadata for cargo. Rust package manager and build tool. This one comes pre-configured with Wasm, bind gent dependency, a few optional dependencies we will dig into later. The crate type properly initialized for the Wasm. Okay. So that's on the cargo.toml. So we're looking at that. And let's see. For lib.rs, utils, set panic hook. Okay, let's see what this is all about. Features enabled. We can call the set panic hook function at least once during the event. Okay. Do we have like our libraries installed for this? Let's look at our extensions. Rust. Ooh. Let's install our Rust utilities as well. Okay, so this should fix some of the highlighting because I was wondering why it wasn't showing up any of these. Rust up not available. I just did that. Really? Let's see if we can get Rust completely integrated here. Rust assist, maybe? Extension pack? Wow. So many things. Keep that over there. Goodbye. This is good. I'll keep this here just so we can push it out of the way. librs. So greet, hello, Wasm Game of Life, and looks like we're getting Wealloc. This is Webassembly Allocation. When the Wealloc I'll never know what this is. If I don't know, let's Google it. A Wii allocator and Unix environments cannot move in memory. Typically not an issue if you're just using static living allocator. Okay, so itself as constant net. Okay. Trait implementations. Interesting. Cool. So let's try to build the project. Use Webpack, Wasm Webpack to orchestrate the following steps. Ensure that we have Rust 1.3 or newer, and the Wasm 32 unknown noon target is installed via rustup. So let's just do Webpack build. Okay, let's try it out. Okay. Oh, I did change that, didn't I? Maybe I shouldn't have done that. Let's try that again. Ooh, something's happening. Cool. Checking for a Wasm target, compiling to Wasm. Got some Unicode. Okay. We're getting somewhere. Cool. Okay. The README copy is filed from the main project, but the others are completely new. This Wasm file was a binary gesture created by the Rust compiler. Let's see. This JavaScript file is generated by a Wasm bindgen that contains JavaScript glue for importing DOM and JavaScript functions into Rust. Tight. So it looks like Wasm gameoflife.javascript. Let's see if we find it. Okay. So this is pretty much JavaScript here. Okay. Export function greet. Okay, Wasm greet. Alert get string formatism. Nice. To anybody just joining up, we are doing a Rust tutorial, and we're going to be implementing the Conway's Game of Life. I just played a video. If you guys want to check that out later, it's pretty tight. All right. So let's see what we're up to here. So this is the JavaScript file that was created. .dts contains a TypeScript file, type declarations for the JavaScript glue. If you're using TypeScript, then you can use your calls in the WebAssembly functions type checked, and your IDE can provide auto completions and suggestions. If you're not using TypeScript, then you can safely ignore this. It's all good. Let's look in the package.json. Okay. Oh, that's me. Okay, so the files are pretty, for TypeScript. So we got this. So it looks exactly the same. Putting it into a web page. So we're really going to just npm init a whole new app right here. If we create the create Webassembly project template, rerun this Wasm, okay. So let's just run that right here in our file, the npm init Wasm app. Ooh, here comes our little Krabby again. WebAssembly. It's tight. It's gonna be my. I love that. I'm gonna paste it somewhere so I don't lose it. Just so I get that crab emoji. Okay. Okay, so let's just look at this new subdirectory that we have. www. Okay. Blah blah. So once again, let's take a closer look. So we have a new package JSON. Comes pre-configured with Webpack and Web App Dev Server. Let's check it out. Click. So this is like a. Okay. Create an app to consume Rust-generated Wasm packages. Pretty tight. So this URL was generated from createwasmapp.git. Very cool. Thank you, Ashley Williams. Okay, we're going to move that in here. So we have the webpack.config. This file configs the webpack and local development server. It comes pre-configured, and you shouldn't have to tweak this at all to get webpack and local development server, so we're not going to. Hello, Wasm pack. This is the very simple bootstrap.js and very thin around index.js. Index.html. Yes. This paints WebAssembly. So we can get the bootstrap. Click. 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 Okay, dependency graph that contains any Wasm that must be imported asynchronously. This bootstrap.js file does the single async import. So no one else needs to worry about to do it again. Very nice. Okay. Well, thanks. And here it is. So we get import everything from Wasm, hello wasm.pack, and then we're going to make greet happen. So let's do npm install there because this is a new npm installation. Npm install. Oh, let's go into there. Excellent. Okay. Ooh, 354 vulnerabilities. I will do nothing about that. Note that Webpack is not required for working Rust and WebAssembly. It's just a bundler and web developer we've chosen for convenience. Parcel and rollup should also be supporting WebAssembly as eCMA script modules. You can also use Red and WebAssembly without a bundler if you prefer. Oh. Using our local Wasm Game of Life package. Okay, so rather than using hello Wasm package from RPM, we want to use our local Wasm Game of Life package instead. This will allow us to incrementally develop our Game of Life program. So open up the package.json. Okay. Now which one? Open up next to dev dependencies and put dev dependencies. Add this line. Copy. I'm going to do package.json. So we have our next key value pair. Get rid of this junk. So these are key value pairs. We're just going to keep them separated. And we're going to import Wasm Game of Life. Okay. Instead of that, index.js. I'm going to save this one and do index.js. So it looks like it wants us to from here. It's doing that. No. Yes. Save. Okay. So, okay, we've declared a new dependency. We need to install it. npm install. Do that real quick. See it. Clear. npm install. See that do it. One package was installed. Excellent. npm run start. npm run start. Now that should work. Fail to compile. Tight. Why is that? How we spell it? Save that. npm install. Should do it. Maybe I'm doing something wrong. info from Wasm pack? Oh, that could be it. Let's run the start now. Okay, looks like something's happening. So Bootstrap is running on the local host. So there's like a little alert came up. Hello, Wasm Game of Life. That's it. That was like that little alert. So it works. If I refresh the page, it would give me another alert. Tight. Okay, well, we know that's like our sanity check. See if something works. Okay. Hello. Okay, that did work. Anytime you make changes to reflect on, just rerun webpack build within the Wasm Game of Life directory. So if I make any changes, I'd run that. Cool. It's never used. Okay. Probably because we're not done. Alright. No, if you're already familiar with Commonwealth Game of Life Fitness rules, feel free to skip to the next section. Okay. So I think we kind of spoke about it a little bit earlier, but let's speak at it again. It's fine. So we got the universe of the Game of Life, the infinite two-dimensional orthogonal grid of squares. Okay. Very cool. Let's just keep on going so we can keep moving. Okay, so we're talking about these pulsars, spaceships, glider gun, and this is the video that we played before. We can play it one more time. Very cool. So this is the end result that we're trying to get to. Let's just give it a couple seconds. Okay, cool. So that's pretty visually appealing. Compute by hand the next tick of a... I'm not going to do that. Sounds like work. Okay, design. Before we dive in, we have some code design. So the Game of Life is played in the infinite universe. Okay. But we do not have infinite memory and compute power. Working around this is rather annoying limitation. Usually comes in one of three flavors. Keep track of which subset of the universe has interesting things happening and expand this region as needed. The worst case in this expansion is unbounded and the implementation will get slower and slower until we eventually run out of memory. Fixed size universe where the cell has edges and fewer enables than cells in the middle. Downside of this approach is that the infinite patterns like gliders can reach the end of the universe and are snuffed out. Creating a periodic universe where cells on the edge have neighbors that wrap around to the other side of the universe. Because neighbors wrap around the edges of the universe, gliders can keep running forever. And we will implement the third version. Okay. Cool. This is one of the more important concepts to understand. So, okay. So, JavaScript's garbage collected heap where objects and arrays and DOM nodes are allocated. This is distinct from WebAssembly's linear memory space, where our Rust lives. WebAssembly currently has no direct access to the garbage collected heap as of April 2018. This is expected to change with interface types proposal. Okay. All right. JavaScript, on the other hand, can read and write to the WebAssembly linear memory space, but only as far as array buffer of scalar values U8, I32, floating 64, etc. WebAssembly functions can also take and return scalar functions. Oh, okay. So this is what we said about before. Well, Wasm bindgen defines a common understanding of how to work with compound structures across the boundary. It involves Rust structures wrapping the pointer in a JavaScript class for usability or indexing into a table of JavaScript objects from Rust. Wasm bindgen is very convenient. This does not remove the need to consider our data representation, what values the structure should pass across this boundary. Instead of it, think of it as a tool for implementing the interface you choose, interface design you choose. Okay. Okay, we want to minimize copying into and out of WebAssembly linear memory. Unnecessary copies impose unnecessary overhead. And minimizing serializing, deserializing, similar to copies, blah blah, and reduces overhead and impose copying as well. If you can pass opaque handles into a data structure instead of serializing it on one side and copying it to some known location in WebAssembly. Okay. Okay. So let's look at this. We have indices, we have the arrays and rows. To define the array of each cell given at the row, column of the universe, we can use the formula index row column universe. Okay. Row times width of the universe plus column. We have several ways of exposing the universe cells to JavaScript. We begin with implementing standard format display. Let's check it out. Ooh. So it's function format at self, so it passes in an immutable formatter, and it returns a result of anonymous and also error. Display is similar to debug, but display for user-facing output, so it cannot be derived. Okay. Required methods. Formatter. Cool. So let's begin by removing the alert import and the greet function from our Wasm librs. Let's go back to librs. No music while we work. You have the wrapper U8 so that each cell is represented as a single byte. It is important that the dead variant is 0 and the alive variant is 1. So we can easily count a saves live neighbors with an addition. Let's define the universe. The universe has a width and height, and the vector cells of length and width times height. Okay. To access the cell of a given row and column, we translate the row and column into an index that the calls vector as described earlier. Okay. So we're going to have, we translate a row column described earlier, so we're going to say get index. So we got to make a whole universe pub struct universe. Okay. Get index. Okay. In order to calculate the next state of the cell, we need to get a count of how many of its neighbors. Okay. What is this? Oh, this can run it? Nice. Function live neighbor count. So it looks like this accepts a row of 32 and column of unsigned 32. We get let count equals 0, delta row. So it looks like the difference in the row and the difference in the column are from the width minus 1 at 0 and 1. Okay. Let neighbor row is equal to row plus delta row modulus self.height. Pretty self-explanatory. And I guess count by itself will return the count. Okay. Looks pretty good. Okay, the live neighbor count uses deltas and modulo to avoid special casing the edges of the universe with the if-s. When applying the delta of -1, we add self-height to 1 and let the modulo do its thing, rather than attempting to subtract 1. Row and column can be 0. If we attempted to subtract 1 from them, we would be an unsigned integer for overflow. As we have everything we need to compute the next generation, let's see. Straightforward translation to one condition on a match expression. Additionally, because we want JavaScript to control when ticks happen, we'll put this method inside of a Wasm bindgen block, which then exposes it to JavaScript. Okay. Let's add that. Okay, so it looks like we're iterating everything inside of for row. It looks like this is a spread from 0 to the height. So that's so column from 0 from the width. So col is here and row is here. Excellent. So it'll iterate square. So see, next match cell and its live neighbors. Rule 1: if any live cell with fewer than 2 neighbors dies. Okay, so if from the class cell alive x if okay. Okay. Next cell, okay, is the IDX that is from getIndex. Okay, self.getIndex is therefore here too. So we're talking about this new instantiating the new universe. It has it inherits self. That's why we're getting this pointer to self, and that we're running that method over the neighbor and the row, which is accepted here as a row and a column. Very cool. So far, the state of the universe is represented as a vector of cells that make this human readable. Let's implement a basic text renderer. The idea is to write a universe line by line as text. And for each cell that is alive, we print the Unicode character black medium square. For medium dead cells, we print a white medium square. By implementing the display trait from Rust's standard library, we can then add a way to format the structure in a user-facing manner. This will automatically give us a toString method. So implement display for universe. So this is a whole new. Okay. So let's add this to the top. Let's see. Okay. Finally, we define the constructor that initializes the universe with an interesting pattern of live and dead cells, as well as a render method. So let's make a new function, public function new. Recompile that with Rust Wasm pack build. Let's see if that actually runs. All right. So let's go to the index.html real quick. Let's add a pre-element to the Wasm Game of Life just above the script tag. Okay. Where's the script tag? But where's the script tag? Okay, just above it. Okay. With the pre-sender in the middle of the page, we can use the CSS flex boxes to incorporate this. Okay, let's see what we got here. The top of index.js, let's import this. Let's save this. Also, let's get that pre-element that we just added. Okay. JavaScript runs a request animation loop on iteration. It draws the current pre, then calls universe.tick. Okay. Let's add that. By starting this rendering process, all we have to do is make the initial call for the first iteration. Okay. See if this runs. Let me do npm install just in case. See if this works. npm run start. Ooh, I get so nervous. Okay, it says it's there. Why isn't this working? Close that. Close that. npm run start. Let's see if that can work. Compiled. Doesn't mean anything because I don't see nothing. Do I call this twice? Now that's what I'm looking for. We have that. Okay. Okay. I think we need this. Save that. Save that. Close it. Close that. This is pretty good, I thought. Oh, let's do the Wasm build. I don't think I did that. Wasm build. Maybe I'm not seeing what's being drawn. Something's happening. It's being served out. Let's do that live debugging then. So script does happen twice here. Maybe that's the problem. Save that. Come back around. I don't know if this has hot reload. I think it does. Maybe it does. Perfect. Nothing's working. No one said this was going to be easy, guys. Just necessary. So let's add a pre-element to the Wasm Game of Life HTML to render the universe into, just above the script element. So maybe we do need that. Let's add a pre-element to the Wasm Game of Life to render the universe just above the script element. So that's including it or not including it? It's not really certain. We want to see preference. So this is going to be alright, we're in the index here. Okay, I get it. Okay, this does have hot reload. So if I change this ever so slightly, it does. Okay. Okay, bootstrap. Very nice. At the top of the Wasm Game of Life, incorporate Next.js. Okay. Alright, I got universe. Also, let's get that pre-element we just had. Get element ID. Pre is equal to that one. Okay. Universe is equal to new universe. Type. And the JavaScript renders render loop. Okay. Pre.context. Okay, save. should look awesome. But why don't mine look awesome? Okay, it says it's run. Let's check it out. So big, yet so small. What the heck? So far, everything works, but why? Why? To start the rendering process, use the same code as before to start the engine's iteration. So draw grid. Okay. Const draw grid. Okay. Yo, thanks for everyone who sticking around. We're going over time right now, but yeah, hopefully we can get this working before the end of the stream. This looks like this needs to be on the JavaScript side. This does not look I should have added it to here. If I can get this to work, then I'd be really happy. This is just never used yet. Let's get this to run. Make sure that's there. Aha. Okay. I think that would be better. Oh, let's just hope it works. If I get this to work, then I'll be happy. Oh! What if this has like a... So, do we have to actually make the call to start the call? Maybe that's what's wrong. And nothing. Wow. I'm not going to give up. We're going to do it live. What the heck is going on here? To the head environment. That should be it. The top of Wasm give. Let's fix our import. Okay. Does the universe have that function yet? I don't think I gave it tick yet. No, we have tick right here. So toString is not there. Holy. Publishing it? Okay. Okay, you should know. Okay. theme. No, where are we at? Ooh, awesome Rust and WebAssembly. What if they give it to us? All right. Well, we're running out of time tonight. We're going to go over the stuff that we learned. And hopefully we can, I'll put a GitHub repository of the code thus far. And then I'll pick it up during the week. But it seems like a really intense Rust overload. Let's check this out 1 second. Let me try to pull up the... Yeah, but thanks for joining this Dev Wednesday. We're going to continue working on this code slowly over the iterations, but everyone who was sticking around, thanks for joining. And I hope to see y'all later. All right, thank you.